Good morning, everyone. First of all, I'm sorry if I cannot do this in Portuguese, but yeah, I don't speak Portuguese. Speak a little Spanish, but not Portuguese. So yeah, my name is Navid Sheikhol. I work at Facebook, and today I would like to talk to you about Facebook Job Engine, which is a system we have developed at Facebook for writing automation that works at our scale. So before I actually start talking about FBJE, let's talk a little bit about how we got to building it. And I think the best way to do this is by telling you a little bit of history and the story of how we got here. So perhaps this is something you can all relate to. Let's imagine that you have to do some sort of operation on your infrastructure. And the workflow that you have to perform is somewhat complicated. Now, just as an example, imagine that you have to update the kernel on your machines. And let's assume that you don't have one or two servers, that you have thousands or perhaps even more. So doing this operation, I don't know what's going on. Doing this workflow is time consuming. Like upgrading the kernel, for example, means downloading the kernel, installing the kernel, stopping the services on the machine, rebooting the machine. That might take some time. The machine comes back up most of the times. When it does, you have to ensure that your services are running again, that there's no regression in performance. These are all typically sequential operations that you have to perform, right? And it takes a long time. Especially when you have to do it on a lot of machines. So ideally, if you were to build a solution that does this for you, you would want this solution to allow you to easily monitor the progress of your rollout. So you would want to have an easy way to access the logs. And ideally, you would want this thing to run mostly unattended, meaning without you having to watch it all the time. So it just clicks through all the different stages, does the thing that it has to do, and then at the end, you get perhaps a notification that the task has been performed. And if along the way there is any problem, let's say the machine is not coming back up or whatever, this is just an example, by the way, but you would want to get some sort of notification, an email, so you can go there and see what's going on. And ideally, you would want to be able to go in, fix the problem, whatever it is. For example, I don't know, maybe the machine was stuck at a boot prompt, but it doesn't really matter what it is that went wrong. Sometimes things are going to go wrong. But what you do want to be able to do is to fix the problem and then continue from where you left off, right? You don't want to go back from square zero because maybe you've already installed the kernel, maybe you've already done all those things. Or a different example, maybe you've already copied the file, maybe whatever it is that you're doing on your infrastructure. So here are some ways that this can be done. In the example of upgrading the kernel, aside from running a cron that updates the kernel on every machine, that would not be very safe because you have no central control of the rollout, right? So typically what we have done at Facebook is to, and what many companies do is to run some sort of automation script from a management host. So you have a dedicated machine that you use to control all other machines on the fleet. Sometimes this management host could even be your own laptop, right? Doesn't have to be a dedicated server, depending on your scale. But this has different issues that at least we encountered. Well, the first problem is that it doesn't really scale. If your infrastructure grows to the numbers that we see in our infrastructure, one machine just wouldn't be powerful enough to drive all these workflows, right? So that's the first problem. But it also means that you may have access to your laptop or that machine, but not everybody else in your company might have access to that. So that's a security problem because you may have to give them more access than you want to give them when they should just be able to see whether their machine has been upgraded or not, or whatever it is that you're doing. But it also means that, they might actually not be aware of the fact that you're doing this operation, and they do something else completely unrelated, and maybe they take too much capacity out of your infrastructure, and suddenly you don't have enough capacity to sustain your production load. And that means that your users start getting timeout and errors, so that's not a great experience. And what happens if you need to reboot that laptop or that management server? Now remember, these upgrading or whatever it is that you're doing might take a long time. Might take, in our case, it takes months to, sometimes even longer than months, to do a full sweep of our infrastructure, right? Because we want to do it slowly and carefully. We don't just upgrade all the kernels or software or whatever it is that we're doing. So you cannot keep your laptop on at all times, right? Or a management server, you may have to reboot it for whatever reason. Or even worse, it might hang in the middle of it. And then you have no idea how far down in the upgrade process you are. You're going to have to go back and look at all the servers and be like, okay, which ones did I upgrade? Which ones did I not? That's a problem. That was a problem for us. Okay, so just to summarize, we have three major problems in that approach. The first one is hardware volatility. It's what we just talked about. Hardware comes and goes, and we cannot rely on that hardware remaining available for the entire time. The second problem is visibility. Other users may not have visibility into what you're doing, and that leads to duplicate work and conflicts sometimes. So again, not great. And then the third point, it's also quite important for us. The environment might be different. So even if you are able to run this script on your laptop and your colleague can run it in his laptop, the same script, your environment might be different. You may have different versions of Python, of libraries, of binaries, what have you. So these differences mean that you will end up with different results, different outcomes. And then you will spend a lot of time trying to understand, why did it work for him? Why didn't it work for me? So these are the problems that we were trying to solve. And there is a couple of more things. Being able to pause and continue your workflows. It's related to the fact that if you have any problem, you want to be able to go there and fix it. Pause the workflow, fix it, and then continue from where you were. So we wanted an easy way to do that. And then scalability is what we talked about at the beginning. You have a large infrastructure. You need a lot of computing power to drive this automation. So now we finally talk about FBJE. FBJE is a service that we've built at Facebook to solve most of these problems. So it's a way to implement scalable automation workflows using Python. Okay, let's start by talking giving some definitions out. Job is what we call a unit of work. Doesn't really matter how big, how small, that's really arbitrary. You decide. Again, referring to the example that we gave before, a job could be upgrading a single machine, but it doesn't have to be that. It could be a completely different operation. I guess what distinguishes a job is that a job has a bunch of sequential things that need to happen, right? One job is executed sequentially. Jobs can create other jobs, similar to processes creating, forking, and creating others, right? And when a job creates another job, you establish a parent-child relationship between the two jobs. So pretty easy. Jobs have an input. So an input is the most common type of input we call entities, and this is just a set of strings that the jobs receives. It's quite abstract on purpose because we want to be able to use that input for different things. So different jobs might expect different inputs. Again, the same example of upgrading the kernel, an input could be the host name we're trying to update, right? So the job takes that host name and knows, okay, I need to connect to that machine and do the operations there. You could also pass like kernel versions or other things, but that's how we use it. Okay, so now we dive in a little deeper into the implementation. Job handler is a Python class, as you can see there to the right. it's the class that you have to implement in order to define what logic will be used to perform, to execute that job. So if I create a job of type upgrade kernel, that class will be loaded on our executors, which I'm going to talk about in a minute. And the start method, which is the first method, will be called. So job handler is the base class, and then you have those methods. I'm going to talk a little bit more about those methods in a second to explain how the flow goes. But I think you can already sort of guess it by looking at this slide. Okay, so the methods, we also call them stages. So each job handler class will have a number of stages. And these stages, well, there is always the first one, which is the start stage. That's required and mandatory, the first stage. And then you can have additional stages or phases, sometimes called. But what's important to understand is that each method, each stage, acts like a save point. Like you know that you've reached that far, and that state is stored in a database so that you can always go back and see like how far down in your workflow you have gone. So in this example, you can see that if I create a job of type upgrade kernel, you would start from the start. You would execute that function there, do something. And then we have these special structures that FBJE understands that drive the workflow. Job transition means, okay, this stage is done, move on to the next stage called next phase. In this case, there's no delay specified, but you could specify a delay in seconds, and it could be a short delay, like a few seconds. It could be a delay of days or weeks or months. What's important to understand here is that if you have a failure at any point in your workflow, your job will stop, and then you will get a notification, and that will be an opportunity to go in and debug what happened. But you can just tell FBJE, okay, I fixed it, try again, and continue from here. So in this example, you have two stages. It's a very simple job. Imagine a workflow that has hundreds of stages. It becomes a very useful feature to continue from the 99th and just complete in 1 minute instead of a month. So every time a job transitions to a new stage, we store this information in the database. We take a snapshot of the state of our state machine, of our job. If there is a delay between stages, we actually reschedule the job at a later time when the time to execute comes. This is important because it means that potentially, but actually quite likely, your job will be executed by a different process from the one that initially executed it, because that machine could be vanished or sent to repair. So you may have noticed that the fact that it's a new process that is processing your job also means that you will not have access to any prior object in memory. So that's a caveat. That's something important to keep in mind when developing with FBJE. I mentioned executors before. So executors are basically just a pool of Python processes that we have on our infrastructure. Depending on how many jobs we have on the load, we can scale the number of executors as needed. The purpose of these executors is to pick up jobs from a queue and execute the stages that we saw before. So it will pick up the job, load the state from the database, and know, okay, this job is this far down, and I need to execute it from here. So in this example here, you see 3 executors. One executor is currently running a job. So this job does something. Then it transitions with a certain delay. Let's say a delay of 1 week. The job for 1 week just wants to sleep. There's nothing else needs to do. So the job goes away from the executor's memory. The executor no longer knows anything about that job. And as we were saying before, the executor could go away. It gets power cycled, it breaks, the disk has a failure, doesn't really matter. What's important to keep in mind is that when the time comes, the job gets scheduled in again, and a different executor will pick it up and execute it. So you might be thinking, okay, that's great, but if you don't have access to the previous memory space, it's hardly useful, because where do you store all your information that you need to perform the job, right? So for that purpose, we have something called context. Context is an attribute of our job handler class that looks very much like a dictionary, behaves very much like a dictionary, but it's not storing the information in memory. So here, I just put a very simple example of how a mutable object like that could be implemented, that from a user perspective will behave like a dictionary, but in the back, it's going to use a separate storage to keep these things. We use an internal key value store that we have in our infrastructure, but you could easily replace that with MySQL or something else that you have in your infrastructure. I guess the reason why I want to talk about this is that one of the winning points for FBJE has been that we provide a very Pythonic interface and way to develop these workflows. So from a user standpoint, they don't have to know all this. I'm telling you because you're Python developers and you're interested in the actual internals. Our users don't care about this. All they know is that they have this object, they can put things in there, and 1 year later, they still have their objects in there. It's very useful for them. So, excuse me. Similarly to context, we also wanted to provide a very Pythonic way to log and to log messages and information, warning, errors, in a way that we could keep for longer retention if needed, and also give visibility to our users. So for that purpose, we have built a custom logger, and we attach it in every job. So again, if you're in a job handler and our users log any message, this message is logged in console, of course, but without them knowing, we're also storing this information in a database and in Hive and in a bunch of other different type of storages. So if 3 months later, somebody says, something went wrong with my job number 123, what happened? We can actually go back and recover logs from many months before because they're stored in a structured database. And we also keep this for legal reasons, right? Like we want to be able to audit anything that happened on our machines, on our fleet. There is another advantage of using a centralized logging system like this, which is very valuable to our users. We're able to auto-generate a lot of alarms based on these logs. We aggregate logs based on their level. So you're gonna have, for each job type, you usually have a certain baseline of info messages and warning messages. We constantly have traffic going through FBJE. So the moment that we detect an anomaly, like a spike of errors or warnings, we can immediately notify, even without actually knowing what's happening, but we know that that's not a pattern that we normally expect from this job. So maybe there is some authentication problem or some other issue, right? And this way we can notify the job owners even before anything actually went wrong. We also periodically delete the logs from the database because database it's expensive and limited in space, but we have a much longer retention for logs in Hive, which we can keep for much longer. So far, all the examples that we went through, we have the pattern has been like do something, sleep, wake up, and do something else, then go to sleep again. So you recognize that the pattern is more like a polling pattern, right? Which works in many cases, but it has certain disadvantages because sometimes your polling interval is too short, meaning that you actually waste resources waking up unnecessarily to check things. when the operation might take longer, there's no need to wake up every 5 seconds to check something that is going to take 1 week, right? But if you make your polling interval too long, then you have the opposite problem. The operation might be finished, but you might be sleeping and not realize that the machine is already up and running for you to put it back into production, which again is a waste in a different direction. Always think that these small optimizations make a pretty big difference when you're talking about large-scale infrastructure. You could be talking about saving thousands or millions of dollars in some cases, right? So we also integrate FBJE with an asynchronous messaging system. And jobs can subscribe to certain topics, and whenever an event is published to that topic, all the jobs that are subscribed to that topic get a notification and they get woken up. So a signal will tell the job, wake up, the thing you were waiting for actually happened. So you might want to do something about it. For example, we have power events on our fleet. Every time a machine gets power cycled and starts pinging again or stops pinging, these are all events you can subscribe to. And that shortens the delay that you waste basically waiting for these machines to come back up and down. I'm always using the machine example because that's a very practical example, but this is a very abstract framework, okay? You can build pretty much anything you want with it. So this is the architecture. I'm just gonna go very quickly over it because I have a little more content to cover, but we have an API that provides access to the system. So we have CLI utilities as well as other services that interact with this API to create jobs and to check on their status, to retrieve the logs. So we have other teams that build very complex systems and services that interact with our service this way to get their logs or all the information they need. The API, pretty much the first thing that happens is to put a job in a message queue that we have. Again, it's an internal product, but could be easily replaced by things like RabbitMQ or similar type of services. The executors that are subscribed to those queues will pick up the job and execute it. Then based on the return status, you remember before we saw that job transition or job complete, it will know whether the job is actually completed or it needs to be rescheduled again. This system could be easily, this asynchronous communication between processes could be easily implemented with something like Celery, right? That I'm sure many of you are familiar with. We don't currently use Celery, but it could be easily built using Celery. The information is stored in a central database, MySQL in our case. And context is what we talked about before, is a key value store, which is where all the persistent information goes. But the executors keep nothing in memory. Basically, as soon as the job is out, everything is garbage collected. So also the memory utilization remains under control. So finally, the value proposition of FBJE is that kind of like Python, batteries included, right? You start using FBJE, you get a lot of things for free. And this is one recommendation I give if you're thinking about building anything similar. Try to give your users as much value as possible. In case of FBJE, we give our users a lot of pre-built dashboards. So these dashboards show the overall stage of their jobs, of their log messages, how many errors, how many warnings, what's the average duration, what's the percentile of the duration. If you have any anomaly, they get notified. Log aggregation is also important. We produce a lot of logs. I don't remember the numbers, but like it's a pretty crazy amount. So going through every single log, yes, you can do it on an individual job basis, but it would be unfeasible to do it at scale. So aggregation is very important. And if you use FBJE, you get that for free. You get many alarms also for free. So what we were saying before about anomalies, if you have any anomaly, any spike of error messages, you will get a generic alarm saying, I don't know what's going on, but something is happening to your job, so go take a look. And also something else quite important, we have automated push processes. We don't want to run old binaries in production because we constantly roll out security fixes and many other type of optimizations. But historically, our developers are a bit lazy when it comes to pushes, so we do that for them. If you commit code to the repository, we automatically run all of your unit tests. When the tests are passing, we have a certain number of integration tests in production. And when those succeed, then your package is slowly, fully rolled out to production. Your executors are rolled out automatically to production. So just a couple of things we learned in the process. In the initial design, we used the database for as a message queue. Yeah, not great idea. Don't do that. Database is great for keeping this type of information around, metadata about our jobs, but it's not made to sustain such a high level of concurrency operations from many clients, especially if these operations are all on the same tables. You're gonna incur into crazy contention. So as our service grew in scale, and now we have a lot of services using it, like hundreds, it became unsustainable. We started having a lot of errors. So we migrated the queue to a dedicated message broker. Again, similar to RabbitMQ, but not RabbitMQ. And our contention improved dramatically. We also used another trick that really helped us scale. We still had to make certain updates to the database because you remember every time we have a stage transition, we have a save point, right? So that means we needed to write to the database. So at the scale that we reached, we still had contention there. We had too many writers starting a transaction, writing, committing, start and commit. So the way we worked around that is that we actually try to do as much as possible asynchronously. So the way we do that is we have, every time a job completes, we put the result into a queue, but we don't write it yet to the database. Then we have a number of processes, a limited number of processes that take all these job results, bulk them together, so they create like a batch of them, and in a single database transaction, commit thousands of updates at once. So this is a lot gentler on the database and allowed us to scale a lot. So I'm almost done. We run millions of jobs every day and many years of runtime every day. So the scale is pretty big. And we run a number of automation workflows within Facebook. These are a few additional examples to kernel upgrades. We also have provisioning of a hot metal, meaning we get a new server, it has nothing on it. We want to install the operating system, we want to install all the packages, all the services up and running. We use FBJE for this. Auto remediation, FBAR, maybe you've heard about it. It's what we use to fix alarms in an automated fashion, uses FBJE. Distributing SSL certificates and rolling out widely distributed binaries safely across the fleet. So yeah, as you can see, we use it for many things, and it's been quite a powerful tool for us. That's it. That was my last slide. Thank you.
Uma pergunta já aqui. Galera, a gente vai fazer umas 3 perguntas. Então, quem mais tiver afim, já levanta a mão.
Hi. Is FBJE available anywhere so we can use?
So FBJE is not open source yet, unfortunately. But it is something that we are considering doing, in the near future, but not yet, unfortunately.
Okay. When you talk about workflow, you're talking about jobs and tasks, but do you have any kind of language for decisions and checks? When you talk about workflow in management, you have a lot of goes and comebacks. Is it this case or only sequential operations?
Yeah, for FBJE, it's actually pretty simple. It's just sequential operations. We have other services that have been built on top of FBJE that leverage FBJE execution ability, but that allow a little bit more complex languages like the one that you described to sort of create dependencies between jobs. But FBJE, we didn't need it for that, so we have not implemented. I don't exclude that at some point we push down those features in the stack and integrate them in FBJE. Yeah.
Hi. So thank you for your talk. Was amazing. But you talked about logs. I don't know if I lost some part, but how long your stores these logs, you know?
After how long do we expire them?
Yes.
Yeah.
There is a specific time for expiring them?
Yeah. So it actually depends on the job type. We have different categories of retention. We have certain things that are more critical that we keep around for longer, and others that we care less about. And so in like the shortest retention is 30 days. The longer retention is like a year. Yeah, so we anywhere in between. Yeah.
Dá tempo de mais uma pergunta. Pode ir lá e a gente fecha.
Hi.
Hey.
Yeah, for this kind of workflow, I know several applications, open source applications, such as some orchestration applications like Puppet, Chef, and Ansible. And Ansible has also Ansible Tower. It has dashboards, and you can have tasks on Ansible tasks dependent of others. So why did you wrote a new a new project, not used some existing like Ansible or other?
I don't have a lot of experience with Ansible, but I think one major difference between the two is that this is it allows you to import and run arbitrary code into your workflow. I don't know if Ansible is the same thing. You can import and run things. Yeah, I don't really have a good answer for that, but I should look into it. I know we have considered Ansible for doing similar things before, but yeah, I don't really have a good answer for that. Sorry. Oh, maybe Gabriel has. Okay, we got another question, and then maybe we can answer his. Yeah.
Hello. You've mentioned that that the system could be compared to Celery. Why haven't you used Celery to build it instead?
That's a good question. The decision was honestly made before I started working on this project. With hindsight, I think it would have been a good idea to use Celery. However, we do use a lot of open source, and we also include open source libraries that are used by Celery. We use it in FBJE. So the goal is at some point to go even deeper and actually leverage Celery as well. We just haven't done it yet, but I think it would have been a good idea to use Celery honestly from the beginning.
Thank you.
Yeah. Oh yeah, I think Gabriel had the answer for the Ansible question. Yeah.
So it's not exactly an answer, but so the decision of building FBJE predates both Navid and I. It was taken before, but FBJE has been around for a while. There are Ansible's popularity is not that old. First, then we have the massive scale issue. We have to run this in millions of machines, which also makes it not exactly easy to take or to adopt external solutions. And then we have to integrate with a lot of internal services. We have services that tell us where our machines are, what services run those machines, integrating something like an external third-party tool that was not really conceived to run random code. It's conceived to execute some steps, but not to run whatever you want. It was. I don't know if that was the factors driving the decision, but I can imagine that those would have made it very complicated to pick up any random open source third-party solution.
Thank you, Navid.